Okay, so we will have more examples for the projectile motions. So we have here another example wherein we are asked to find the maximum height in the range of a projectile given our initial velocity, which is 20 meters per second at 30 degrees. So we have, if we illustrate it using the illustration, we will have to have 30 degrees from the horizontal and you have 28 meter per second na initial velocity. So what we have to do is to decompose this into its initial vertical kag horizontal component. So your initial and vertical component, so we have initial nga horizontal kag vertical component. So we have 28, so cosine 30 for your x component and your 28 sine 30 for your y component. So we have your VOX and VOY as 24.2 meter per second and 14 meter per second for your vertical component. Okay, so take note that at the highest point, so dari sa pinaka-peak is ang aton projectile, your Vy will be equal to 0. Aton the velocity will be equal to 0 sa pinaka-highest peak gid kada permi. So tandaan always. So your formula will be velocity is equal to Vi plus AT. So take note na kada permi, your Vf is equal to Vi plus AT. Diba? Amo na nga to yung formula. So sa diri nga part, here that will be your Vf, that will be Vy is equal to Viy plus Gt. So is equal to, so butang ta, y component at nang gina-consider, so we'll have 14 meter per second plus your gravity, amo naton acceleration, negative 9.8 meter per second squared plus your time or your t. So among is equal to, since kabalo kita ang aton nga final velocity sa sa peak naton is equal to 0, equate siya sa 0. So this time, pwede tadi mo ko ang values ng t. So pila na ang values ng times ang sugod sa pag-start niya hasta sa iyang highest peak. So that will be equal to y max naton occurs when your 14 minus 9.8 t is equal to 0. So mukha tadi ang values ng t which is equal to 1.43 seconds. Okay, so amo na lang values ng aton nga time that it takes for our projectile motion to reach its y max or maximum nga height, which wherein ang aton nga velocity will be equal to 0. So subong, let us find the maximum height naton sa aton projectile given ang aton nga v is equal to 28 meter per second at 30 degrees Celsius. So amo nang ginapangita ta. So maximum y coordinate occurs kung ang aton nga t is equal to 1.43 seconds. So nakabalo na ta sang values ang time, so pwede ta siya gamiton sa aton formula. Your y will be equal to VIT plus 1 half gt squared. Okay, so gamiton ta siya. We have 14 times 1.3 plus 1 half times negative 9.8 times 1.43 squared. So your y will be equal to, y max natin is equal to 10 meters. So muna natin value for your maximum height sa projectile. Next, pangitaon ta ang range. We find the range of the projectile given ang the same nga mga parameters. So range is equal to, kabalo natin ni, equal sang range. The range is defined as your horizontal distance sa lisaton nga diri and then as sa diri man nga point. Okay, so ang iya nga range sa same nga reference point. So the time of flight is found by setting y is equal to 0. So y is equal to 1 half VIT plus 1 half GT squared is equals to 0. So amo ni aton nga formula gid. So we have to find the time of flight TR when the range x then the range XR. So kaunta na ang time naton pares ng hinhimo naton kagina. So we have VIY plus 1 half G 1 half GT is equal to 0. So take note y naton para mangin same sila nga reference point but silingon 0 ni reference ta ni 0 but silingon 0 man di dapat aton y sa sining part. So y naton equate siya sa 0. So VIY plus 1 half GT squared is equal to 0. Okay, so pwede kita maka-divide by t para ang mabili ni sa V o Y plus 1 half GT na lang. So we have, pwede ta ko ang yang time, your V o Y, so will be equal to, so 2, So, kaya ang 1 half gin-multiply naton. So, we will have, so 2 times 14 meter per second divided by negative 19 o 9, negative 9.8. So, negative man siya. Then, may negative pag-get. So, that will be positive na. T is equal to 2.86 seconds. So, but silingon, amo na ang time nga, gin-take niya halin dari, kadto dari. So, that will be, amo natin gamiton for your range nga value. So, V, maghambal ta range. So, but silingon, X lang. So, that will be, ang x naton wala gav change ang aton nga component, so multiply ta lang by time. So VOX times time is equal to 24.2 meters per second. Multiply ta sa aton nakuha nga time, which is 2.86 seconds. So that will be equal to 69.2 meters. Okay, next one. A ball rolls off the top of the table, which is 1.2 meters high, and lands on the floor at the horizontal distance of 2 meters. What was the velocity as it left the table? This time, kabalo kita, nakita naton ang y max or ang aton nga height, which is 1.2 meters high. And then, given man sa aton ang horizontal distance sa iyang movement. Ang ginapangita naton subong ang iyang velocity or initial velocity. Okay, this one is your formula manipulation. Dari naman kita ma-perform. So, take note, halin sa table, 1.2 meters, naka-move sa isang distance ni 2 meters horizontally. So, ang pangitaon ta is your initial velocity. Okay? So, take note, pwede tayo makuha ang R by Pythagorean theorem para makuha ang values ng R. So, we have, okay, take note, your X is equal to VOX, T is equal to 2 meters. So, pwede ta, okay? Your VOY, so both silingon sa pag-start VOY initial tang velocity kay horizontal lang, y ta VOY, so 0 lang, is equals to 1 half AY T squared, or your acceleration, is equal to 1.2 meters. Okay? So, para sa aton nga, horizontal, ay sa vertical nga range. So, wala ta Y, so 0, 1 half GT squared na lang. Okay? First, find t from your y nga equation. Kung tadi ang atin nga t. So, we have your t will be equal to y is equal to 1 half gt squared. So, is equal to negative 1.2. So, t, pwede tadi manipulate ang aton equation. Makuha ang aton nga time, which is equal to your 0.495 seconds. 0.495 seconds. Next, we can now use the horizontal equation to find some values sa aton nga VOX or aton initial velocity leaving the tabletop. So, nakuha tang time. Take note nakuha tang time. So, take note, ari nga distance, horizontal distance, pwede ito makuha ang aton nga velocity nga horizontal. So, that will be, so nakuha ta niya ang value nga 2 meters, and then we have your time nga 0.495 seconds. So take note lang of the formula, which is equal to VOXT lang para sa range or the X nga distance. So that will be equal to VOX times 0.495 nga nakuha naton is equal to 2 meters. So that will be your VOX pwede ito na masolve will be equal to 2 meters times 0.495 seconds. So the ball leaves the table with a speed of 4.04 meter per second. Okay? Next, ang next natin nga question, yung kinangalan isolve, is what will be its speed when it strikes the floor. So, but sa lingon, ang ginapangita din natin, ano na di iya nga? VF. Sa dali nga part. So, your velocity nga component. So, we have nakuha ta na ang your x ka component, so ang kinanglan ta na lang sa mong pangitaon nga value is your y component. So Vy is equal to your Vf ni siya kung sa aton yung una nga formula na to be Vf is equals to Vi plus Gt. So your Vy is equal to G times T. So automatic that will be 0 plus negative 9.8 meter per second squared multiplied by 0.495. Amo ni nga ito niya time. Vy is equal to negative 4.85 meter per second. So, it makes sense nga nga ito nga Vy is negative because kapapanaog siya. So, we have, so, kaunta ang value sa nga ito nga speed or sa nga ito nga velocity, for example. So, we have to make a find the magnitude of your resultant, which is equal to, so Vx natin kag Vy nga resultant is equal to 4.04 meter per second plus, naka-squared plus negative 4.85 squared. So take note, naka-parenthesis ang negative. So solving for this, your V is equal to 146 feet per second. Wait, I have to clarify. Okay, so we have okay, same for the value of your tangent, that will be equal to your arctan malang Japon will be equal to negative 4.85 divided by 4.04. So mukha tada nga theta will be 309.8 degrees. Okay, next, find the hang time for the football whose initial velocity is 25 meter per second, 60 degrees. Okay? So, we have here, so pangitao natin ang time of flight. So, amo nang ginapangita natin. Pila ni siya ang time of flight niya. So, given ang aton initial velocity nga 25 meter per second, so still the same ang aton nga acceleration, negative 9.8 meter per second. So, una-una himuon kada permi is to decompose this one into its horizontal and vertical components. So we'll have 25 cosine 60, 25 sine 60 for your y component. So nakuha ta niyang value sa aton nga x kag y component. So VOY ni guys, so VOY. So we have 12.5 meter per second, 21.7 meter per second. So take note nga ang maapektuhan diri nga parameters sang hang time will be the vertical parameters only. So VOY t plus 1 half a t squared is equal to, so sa diri nga part, so hasta sa ating nga peak point, di ba hamba ko kagina, so basta diri nga part, your uh, so, this one, dali natin, let natin y is equal to 0 here. So, that will be 21.7. So, nakuha natin nga VOX, or VOY, I mean, plus t plus 1 half at squared. Okay, so this one, VIT plus 1 half at squared. So, pangitaw natin ang ating hang time. So, we have, substitute natin ang ating mga values. So, we will have this one. So, para makuha ang ating t. So, that will be 1 half 9.8 t squared. So, we will come up with the values ng time which is equal to 4.42 seconds. Then, for the last nating example here, a running dog leaps with an initial velocity of 11 meter per second at 30 degrees. What is the range? So, ang ginapamangkot sa aton, ano kalayo ang iyang malambutan kung naglumpat ang dog. So, given, so we have initial velocity ng 11 meter per second and your theta nga given. So, kabalo kita, kinanglan natin i-decompose siya into its horizontal kag vertical components. So, still the same, we will come up with your initial nga mga components of your velocity which is 9.53 meter per second kag 5.50 meter per second. Okay? So, pangitaw natin ang range. So, to find the range, kinanglan natin mabalaan ang time when y is equal to 0. So that means kaunta ang value sang y is equal to 0. So that means, okay, equate ni sa 0 para makuha ta. Okay, so take note ha, halin dari pakadto, dari amo ng y nato is equal to 0. So VIT, so same man to kagina sa next nga, ay sa previous nga problem. VIYT plus 1 half 8 squared will be equal to 5.50 5.50 or 5.50 t plus 1 half times negative 9.8 t squared. So, same man siya po natin himuon. So, pwede ka di ka factor, pwede ka di ka quadratic equation, but this one will be medyo mas hapos. But this is not applicable kung ang ginagamit natin is mathematic rules. But pwede lang kung amo nga process ang gamiton. You have divided by ang t both sides. So, 4.9t is equal to 5.5. Okay? So, next, ating nga time will be equal to 1.12 seconds. So, this one, amo ni dahil natin nga gamiton para makuha natin ang aton nga range. So, for the range is found from the x component. So, both silingon ang aton nga i-multiply siyang components ng velocity is the x component also. So, that will be x is equals to x component naton times time. So, mo lang na. So, we have 9.53 times 1.12 is equal to 10.7 meters. Grabe man ang ating nga dog ba? 10.7 meters yun ang nga nalumpat. Okay, so this is it. Sari-sari na itong type of questions but the same lang man siya pang formula ang ating mga din pang-apply. So take note that based on the rectilinear motions, same lang siya pang formula but sari-sari lang pag-atake natin. Same with the free fall and then we have projectile motion. So this is it for now. So, I just would like to present lang summary sa projectile. Determine the x and y components. Amo na ito nung nga himuon. So, pareho nga pang himuon natin sa mga examples. Next, the horizontal and vertical components of the displacement at time t are given by the equation. So, take note para makuha natin ang x or ang aton nga range. So, ang x component lang man natin nga gamiton. So, we have multiply ta lang. So, wala ta y component, so this will be 0 kung sa x nga value. For the y, ang natin gamiton, this will be affected by your gravity. So, we have VOYT plus 1 half gt squared. And next, for the horizontal and vertical components of velocity at any given time t, so, we have kwaon tada ang aton nga v nga x kag y components. Then, velocity displacement or velocity can then be found from the components if desired. So, still the same, amo ni aton nga gamiton for the finding of your r kag theta. Okay, so we are done for the discussion on the projectile.